and then this particular chapter kind of rolls back and does that probability again, and then works its way into other ways to do probability. So now we're kind of wrapping it all up, and we're learning how to find the expected values, also known as the average, really, and then the variance and standard deviation. Okay. So the first thing I want to do is October, November 2006. It's kind of a simplistic one, just to kind of get our brains going this morning.
October, November 2006.
Yeah, October, November 2006.
Number 2 or number 1?
Number 2. So the first thing I want to do is kind of go over the process of how to find the Q on there. They gave you a probability distribution function. Can someone remind me why we would create a probability distribution table?
We can set it equal to 1.
Okay, so the ultimate idea is that all probabilities set to 1, okay?
Yeah.
Why do we do it?
Like if we have an unknown variable, we can solve for it. So like in this case, this one, like we solve for Q.
So you're solving for Q, but let's step back one more time. Before the solving for Q and setting to 1, what is the probability distribution table?
It's to show the probability of like a certain situation, like if you can choose 1 pink or like you choose 5 pinks. It depends on what's the probability of actually choosing one.
Yeah.
Absolutely. So you have scenarios like choose 1 pink or choose 5 pink. So obviously you're going to choose 1, 2, 3, 4, or 5 pinks. So basically, let's step back one more time and talk a little bit more about what was the scenario that we had. Remember when we would write on the board, let X be, and then have something?
Yeah.
What was that little something that we would write? I kept calling it by a name, yeah.
Like the situation, the scenario.
Situation at hand, right. Okay, so when we're talking about our probability distribution table, we have our X,
Yeah.
and then we have, the reason why I'm doing this is so we can kind of figure out what the actual meaning of the E of X is. If we understand what the probability distribution table gives us, then what would E of X do for us? Okay, so that's what today's lesson is going to be. So if we look at this particular one, October, November 2006, they gave us, it says the discrete random variable X has the following probability. So it's 0, 1, 2, 3, 4. Now, I don't know what the storyline behind it is, but what are the 1, 2, 3, and 4 representing? And the 0, sorry, I forgot that number. Outcomes, right, the outcomes of whatever probability we're looking at, okay, whatever storyline we're looking at. Okay, and then in this case, they gave us some really nice probabilities. Okay, fast forward to what Nick said, okay, if the first part of this particular question says, I want you to find Q, how is Nick going to accomplish that? Add them all up.
Set it to 1.
Set them to 1. Perfect. Okay, I think you also had another one in your worksheet that had 2 unknowns. We'll have to kind of talk about that one later. We have to see what happens with that. It's a little odd. So 0.26 plus Q plus 3Q plus 0.05 plus 0.09 is 1. So the beauty is I know how to teach math really well, but I can't add or subtract to save my life. So it's an ongoing joke in this class.
You can subtract, not add.
I can subtract pretty well.
Just be adding.
So it just makes me all like flustered. I get nervous, and so they help me out through that process.
4Q.
So the whole
Q. So it'd be 0.6.
the whole answer.
No.
Oh, here.
4Q is equal to
Okay.
0.6. And then Q is equal to 115.
0.15.
Now, if they're asking you for Q, that's R. I would go ahead and just insert them back in and make sure that I had that right. Okay. Are there any questions on how we found 0.15? Clea, you cool with the adding, subtracting from 1? Yeah, I figured y'all would good. So, what do you get with this one? Obviously, it's 0.15
Yep.
and
0.45.
0.45. Now, could we double check our work?
Yes.
I just
Make sure it adds up to 1. Okay? So, if you find that it doesn't add up to 1, something went awry. Okay? Are we comfortable? Now, the formula, I'm moving this way, yeah. So the formula for E of X, which is also a mean. What does it mean?
Average.
Average, right, okay. Tell me 5th grade definition of average.
Add them all up and divide by the number of how many you have.
That makes excited. Add them all up divided by how many you had. That's like the formula for it, but what is the definition
It's
of
like
it?
an average.
What is it? You're going to use average in the definition, and I learned that. I can't do that. That's a no-no. What is an average? Really, honestly, like think about what an average tells me.
It's a common number between all of them. It's like a middle kind of.
Kind of like a middle between all of them. That would be the median, but it's kind of like the common number they all share. It's like what they kind of revolve around.
Yeah.
So the idea is where they kind of, the center point of that might be, where we're kind of looking. So what would an average of this be? So let's talk about what this is again. This right here tells me when the outcome is 0, okay, 0.26 is the probability that happens, right? Again, when the outcome was 1, 0.15, and et cetera, and et cetera. So the definition for this thing is going to be the sum of x, little x, we know x is the outcome, right? Times p, what's p?
Probability.
Probability, okay? What does the summation do for us? Well, it adds them all up, right? The
Yes.
sigma notation. So I'm going to take each of these guys, I'm going to multiply, et cetera, et cetera, et cetera, and then in the end, add them all up. So can somebody do that for me? You'll use your calculator as well.
What is the x again?
Okay, the x is going to be the outcome. These guys right here.
So I'm gonna do 5 right there.
So we're going to write it out, Kalia, you and I. You're going to tell me what to do. So my x here is 0, and my p is my probability. So my probability that relates to that is 0.26. So what do they want me to do with the x and the p? Multiply them. So 0 times 0.26. And what does this symbol tell me to do to it? Add. That's right.
Oh, okay.
You with me now? Awesome. You add. Not sure.
Yep.
1.56.
You're too cute. And you want me to do what? Okay, so what do you get? 1.56. What does 1.56 mean?
The mean.
EVX, cool mean, yeah. Literally, what does it mean?
Expected variance.
You guys are just giving me what I want to hear. What is it?
Average?
Kind of the average. Yes.
How
So-
is the average
Because-
of all of
That's a
those
good
numbers
question.
are smaller
Thank you.
than-
Oh.
That's a good question.
Because, well, it's the
Because
bottom
it's the-
numbers.
Because the probability happens 3 times for some of those and 4
Because
times.
the
Is that why?
probability of getting a lower number is a little bit stronger than a higher number, and that's why the average is shifted between the 1 and the 2.
Uh-huh.
Oh.
Oh, it's
Oh.
on the little x.
Yeah, it's
see
the
it?
average of the
Oh,
That's why it's over toward that side just slightly, because
I
the
forgot it was
probability of
the
over
little
there
x.
is stronger over there.
26% of the time,
Right.
0 is going to have my
Question.
my outcome. Yeah.
Is it a big X or a
E of
baby
little
X?
little
It's a little x. Did I write it? Well,
It looks like a big X.
Okay,
I'm
so-
kind of confused.
okay,
Yeah,
I'm
that's why I was
sorry.
confused too, but then I
Okay, so,
See that now? It makes
well,
sense.
okay, wait. It's E of big X, but
But
big X is the
equals
story
little
that
X.
represents this
Right,
outcome.
equals
So
little X.
that's a little confusing, I know, because there's X's everywhere. But we have to understand, E of X is the average of the story. The story in this case has outcomes of 1, 2, 3, 4, and each of their
then
probabilities.
that makes total sense.
It's
I know,
E of
fair.
X.
From 0 to 2, you have a lot, and then from 3 to 4, you don't.
Right. So it makes sense that 45% are here. That's kind of high.
That's a lot.
And then these two together,
It's 41.
close to 45%. So the chunk of this happening is somewhere, in the vicinity. That 26% might pull it a little bit back to that 1.56.
Right.
Kalia, can you explain what we just talked about? Because you look like you're.
No, that's not the problem.
Okay.
Confused about is so can you make other letters that like when they give you the letters
They have to be the
them
same
different
letter,
to
though.
that?
They have to be the same letter. I know. All these X's and P's and
Maybe do
Q's and I know.
spades would be easier to dig out.
When you see it though, because remember my beautiful handwriting doesn't always make it really distinguishable as a big X and a little X.
Yeah, like here
Truly,
you can
this
really
is E
tell.
of big X and this is the little X. You know? I mean, it's hard. Does that make sense?
Right.
And variance,
Okay, so let's talk about the actual formula for variance. Okay?
Is it still big X or little?
Big X. So I'm going to erase this, okay, because this is just the work we did to get to this, but I want to I'm gonna put 1.56 was our answer, okay? All right, so variance. Now, the beauty of this stuff is that you don't have to have it memorized, right?
Right.
That's kind of cool because it's right there on your formula sheet. Okay, so this actually kind of looks familiar to me. I'm gonna write it out. That's little
X squared.
Kalia. That's little x. Okay. Now, I don't know how they write it on your little formula sheet, so I'd like you to look at it for a second and tell me, do they have parentheses around it? And if not, I don't know why not, because it's a little confusing when they don't. A lot of people don't.
They do.
They do.
I took a bracket for purchasing.
Okay, so I need to look at it. Oh, yeah.
Just brackets. It's the
Yeah.
same thing.
Okay, good. Some professors don't put anything around there and just put squared out there. Confusing to me. I think you need to have some form of. That's stupid. I agree.
That's stupid.
Don't let them do
Order
it.
of operations.
Right.
Okay, so tell me what you do, Kalia.
Okay, so you take little x and square it,
Okay.
times it by the probability.
Yeah.
Add them all up.
Yeah.
Subtract that number right there is squared.
That number itself squared. Look at you. So you just figured out how to do it without me teaching. I'm done. Now I'm going to sit down. Yeah.
Wait, why is it that number squared? Should there be a p in there?
Remember, E of x is the summation of xp.
Oh, that's an e, not a sum. Okay.
Doesn't it look like an E? I
It
tried.
doesn't.
Oh, okay.
It looks like an e. I just forgot that e was a thing, and I was like, oh, she must mean sum.
It must be something. Terrible handwriting. And they make sure, yeah. We all are very appreciative I teach math and not English. All right, so variance of x. Now, so the summation, and Kalia told me I'm going to take 0, square it, times 0.26, plus 1, square it, times 0.15.
Oh, man.
What, you don't want to do it anymore?
No, I did
Oh.
0.15 squared.
Oh, no, yeah, that would have, that'd be a problem. Okay. Times point. So, tracking this whole thing is not fun. Oh, 0, 9. Okay, so, I'd like you to kind of work your math magic there. Are you getting, for the whole thing?
For the whole thing, minus 1.56 squared. So I got 3.84 minus 1.56 squared equals 1.4. Wait, what?
Yep.
Okay, squared.
We like to go 3 decimals out, or, depends. Now, so the question was, what exactly is the variance?
Variance between each probably.
So you used the word varies. No, I'm glad you did, because variance is a derivative of
Isn't
that.
it like the things that like they can go like this many distance from like the mean, or am I looking up the wrong thing?
Like the bell curve?
The bell curve, which we're going to learn. We're
that
going to
what
work on
I'm
that. We
thinking
haven't done that yet. But you're absolutely right. It's the measure of the spread about how far your x values are.
Little x.
That darn x is kicking our butt. It's the little x's.
Okay.
Like, the idea is 0 happens 0.26% of the time. We've kind of done this before, and it would make better sense. If you remember histograms, and we did our information with histograms, and we would square it and add it all up and multiply it by something, and then remember, we did variance from that. And that made better sense that, like, if you had 5 of the values of 1, and you had 7 of the values of 2, and you had 8 of the values of 3, and you wrote those values all out, what was the measure, the spread of those x values that happened? Okay, it's the same kind of concept here, but it's a little harder to see with percentage values beside it. It's figuring out what the spread of those numbers are. In this particular case, the spread of it is 1.406. It'll make better sense when I teach you the normal bell curve and we start talking about variance and standard deviation. You will have a visual of exactly what variance does for us. Meanwhile, we're just kind of going to get it, and we're going to kind of, because we're not doing that until after they test for paper 1, I'm going to introduce the bell curve, and because I need time. Yes, you had a question?
So what's the difference between standard deviation and variance?
Well, the standard deviation, okay, so I'll show you that, and then, does anybody have any more questions about how we got that? So Kalia did a good job telling us how to do it, so we're good to go. One thing that I'm going to also introduce to you today is the standard deviation, just how to get it. Okay, the standard deviation is the square root of the variance of x, little x.
Pretty simple.
Pretty simple, okay? And I think they give that to you on your bright color sheet of paper? No? Not so much?
It wasn't with the other one.
Was not.
So, in this case, it's 1.19.
Is that what it is? You guys got it?
Yeah.
So in this case, it's the square root of 1.406. You said what was it?
1.19.
Thanks, babe. So 1.19.
Yeah, it's not on there.
Not on there. I think you guys would be okay though. No? Yeah? Maybe? Let's see if I can.
That's easy enough to remember.
What's that, hon?
That's easy enough to remember.
I would think so. Is it on there at all? Anywhere?
It's on for the grouping, the ones we, like the old ones.
Okay.
But it's like not for this exact
Okay.
one.
Well,
Standard deviation for the ungrouped data and the grouped data is all they have.
okay. So back in 2006, this would have been a 5-point problem. Bless you.
Thank you.
Okay, so we talk a lot about at the end of doing every problem how we would pull our points for that particular item. In this case, where do you think your points would have come from in finding the value of Q? Evidently, it was 2 points.
Yeah.
Yeah.
Set it equal to 1,
Set it equal to 1.
And then solving for
solve.
Q.
Absolutely. So when you're taking that test, if I know that I can set it equal to 1, and I know for a fact that happens, and I know I solved for X or Q correctly, I know I got my 2 points. How about the next one? Find an E of X and find variance of
We're
X.
finding the E.
So finding E probably would have been worth 1 point. And then-
square it.
And then when you squared it, would have been another point, and then actually plugging it into the formula would be your last point, the third.
And then getting it correct.
And getting that answer right, yeah, yes.
So what would you do if there were 2 variables?
It's not one that we're gonna do yet. You're pushing me over the edge with that one. We're gonna have to work on that one, probably, we will.
Is that like when you use substitution,
And
you're
give
going to
you
have...
some other information that
Yeah.
you're gonna have to utilize.
Are we gonna have a test this week?
Yeah, you want to?
No.
Friday.
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 Because right before spring break.
Yeah. Are you gonna be here?
No.
No?
I don't know.
Bad person.
Are you already? One that you don't have. Don't get excited. Mary Ellen. She's already rolling her eyes. Not a challenge. On Friday, we'll include variance and expected value of X. And then the weird stuff we did on Friday, yes. So it'll be a little bit of both. Today, we're gonna focus on the variance and the expected value and standard deviation. I'm just gonna throw that one in. And then tomorrow, we'll start working problems that correlate to that. Are we good? Okay. And yes, it'll be a test. Has anybody started working on their take-home test?
Yes.
Yeah?
Yes.
Yeah, don't wait, please. Don't
Wait, when is it the Monday after?
It's due the Wednesday after, the 20th, I believe is what I put. I think I give you a few days after.
20th.
I don't want you waiting until the day you come back. Yes.
And you'll be here in the morning, like, or if like we had any questions on the take-home test, like, you know, how do we do this?
My game, and you have my cell phone number.
Yeah.
Are you going anywhere for spring break?
No, I'm putting a new roof on my house.
Oh, we did that last spring break.
Yeah.
Is it 19th or 26th?
Are you getting a metal roof?
No,
We gotta get a metal roof.
it wasn't happening.
Yeah.
He came back around.
I'm should hire him.
Oh my
Okay,
gosh, you're doing
so,
that yourself. That's
This is a challenge one from, let me see.
Just keep her though.
Sorry, I got busy
It's
talking.
$8 versus the
This is from October, November 2012.
So fairly recent.
Fairly recent. Okay. The discrete random variable x has the following probability distribution table.
Okay, what our number are we on?
I'm sorry, it's right here, number 2. Okay. So they're giving you a probability distribution table, and as Nick wished,
I thought we weren't doing this way.
I'm just kidding. It's not what he's wishing. You'll be okay. They actually give you the E of x,
Yeah.
And variance.
and they give you the
It's
variance,
just putting variables.
and they want you to find.
Substitution, elimination, system of equations.
Maybe not.
Wait,
What?
let's just try it. It'll probably
Right.
make sense.
You can use your desk, you can use your paper, I don't care.
It'll make sense when we try. Plug them all into the equals 1 equation. That's p plus q plus r plus 0.4 equals 1. Or you can do that, move the 0.4 over. You can also plug them into the e of x formula, where it'll be like the negative 3p plus 0q plus 2r that, and that already cancels out the q for you in that one. And then you can do system of equations and either substitution or elimination and figure out the variables.
Isn't that exciting?
Yeah.
It's exciting, and the fact is, that I taught that just now, and they can kind of pull it together from that, which I love. And some of them don't want to do that on their own, but we make them.
Only one person figured
What do you
this out. Look at everyone
They can
alone.
help for two. So they have.
figured it out if you just look at it. I just
Really,
spoke to you.
Really?
I believe it.
So who's going to take him in with us as a partner for the ACE exam? Cleo.
I wish you could do more.
I know. They always say, I wish you were in my pocket, Miss K. I'm like, no, people would talk. I can't go in your pocket. Can't tell you what to do.
Q in my backpack.
I can go in your backpack. You can't bring your backpack into the test.
My plastic baggie.
Yeah, right. They'll see me.
You're always standing there. Just putting on.
Yes, that's what's wrong with that
It's
plan.
Cassie.
You're going to be giving me the look.
I'm gonna wanna right or wrong.
Right or
That's a
wrong.
comically large plastic bag you've got there. That's about human sized.
Why is this K in it?
Oh, I didn't
Why
even
is it
notice.
your
I
bag?
like
What is it even?
I'm
You'd be
like
dragging that
Dunkin'
puppy
Donuts
into the
muffins,
test,
and
I
I'm just gonna
promise.
delay it.
That's just my calculator. I have a lot of calculations to do.
You also not adding them.
Listen, Ryan, you're in desperate mode if you're using me as your human calculator.
No, we just won't have you to add. We have two calculators. Everything else
Unzip
is
the
but
bag and
adding.
whisper, what's
You
two
just
times
square
three?
root. You can like square them.
Right in my head. Okay, does anybody want me to just set up the equations? Does
Yeah.
anybody-
Yeah.
Okay, so, you wanna try? Okay, so. You and me? Just you and me, everybody else
I
wants to
want,
try it.
no.
Oh no, Cheryl wants to come too. Okay, so, while the others are still working, which is, I'm excited about, do you understand that they're actually giving you the E of X answer? So that's one equation. And they're giving you the variance answer, so that's the second equation. But the last thing that you have to remember is that this plus this plus this plus this equal 1. That's the third equation. Why in the world would we want 3 equations? Because we have 1, 2, 3 unknowns. When we're solving 2 equations with 2 unknowns, you guys have a comfort level with that.
Right.
Okay? Because you've been doing it for so long. 3 equations with 3 unknowns, you might not have seen it in a while.
Right.
Oh, Kalia, you with me there? Okay, so at least try to write your 3 equations down. I bet you pull points for that. Okay? Okay, so go ahead and write them down. I'll check to see how you're doing.
So you think, okay, hold on.
Yes.
And you know what I'm noticing is that like the P seems, or the Q seems to cancel out because we have 0 Q.
Absolutely.
And then so we're really only having 2 variables, but
You get the
how are we,
Q in the other one.
But we do have the Q in the other one.
the Q, yeah, so then I get this, and then, yeah.
So you want us to set them up?
I think we talked about together.
Right.
P plus Q plus R is, plus 0.4 is 1. Anybody have issues with that?
Wait.
Ian, are you good? Whatever.
Oh, I accidentally wrote .04 and that messed everything up.
Yeah, oh, yeah.
Yeah.
I wonder what they would do as far as points for that. If you mess up once, they'll kind of take your mess up and then hopefully not, like, mark you wrong the rest of the way. A lot of times they'll kind of, take care of business. All right, what's the next equation going to be?
Negative 3.
Negative 3P
Plus 0Q.
plus 2R plus 4 times 0.4
Not 0.04.
equals 2.3 because they gave you the expected variance,
Nice. Is everybody cool with that?
or expected value, yeah.
Okay, Jake, I think, got that next one, but I want to make sure everybody else did as well. I went by, I was really proud of him. What's the next one tell me to do?
Do you have to write the 0 Q?
No, we'll clean it up. What do we do? Square it, and then, okay, so 9p. So I'm just gonna write 0q just for, and give us. Plus what?
4R plus.
4r, sorry.
Yeah.
and then plus 16 times that,
6.4.
minus,
2.3.
yes, that's what I was,
Equals.
minus 2.3 squared,
Equals
Equals.
3.01.
3.01. Beautiful.
Mhm.
Okay, did everybody, how? Okay, that's why I want to make sure we're on the same page. Jamie, can you tell me where the how came from?
I'm not sure it was a 0.23. I know it's the what you call it. How do we find 0.23 in the second equation?
Okay, that's a good question, like here, down here, or here?
Yeah, on the top one.
This one? Okay, directions say E of x is 2.3, and this is the actual formula for E of x.
Okay.
So does that make sense?
Yeah, and then you should deal. Okay.
Yeah, and then we actually use the 2.3 again, because it's, remember, squared times p, squared p, squared p, and then minus E of x squared. Is anybody else with a how?
And should we put like variables together in the first equation?
I would line them up, because,
So
That's
we
what
have
I
to put
did.
those together since it's only one, it's only P, Q, R, one without.
right. And so what I would do is subtract the 0.4 over. I would take care of business, subtract it over. I would square it, add it over, and then subtract that over. I would clean up my Q's.
Mhm.
Now it becomes a pretty decent problem to handle.
Yes.
I love this problem.
Okay.
I know, it's crazy. I just think it makes you think a lot. Go ahead.
Would you consider this to be like one of the hardest types of problems with this?
I don't know whether you really have extreme hard stuff here. I think this, because it brings so much algebra 2 into it, I don't think it's a hard problem. I think
Yeah.
when we take what we learned on Friday, when we're doing the probabilities, we're incorporating it into a probability distribution table, then we're finding the EX and var of x. I think that's when I consider them a little bit more difficult. I'm not thinking that really this lesson is hard. You know, I'm pretty truthful.
So then on Friday we'd just have variance, standard deviation,
E of x.
right? E of
And
x.
then what you learned on last Friday, where we actually, instead of the tree diagram, where we took the probability, when we did like 3 choose 2 times,
Yeah.
remember like the green pepper, red pepper, yellow pepper type problem?
Yeah.
We'll go over lots of them this week. Okay. So I just needed you to have the tools to be able to be comfortable with the problems.
Mm-hmm.
So, does anybody need a refresher course on how to solve 3 equations with 3 unknowns? It's been a long time.
Yeah.
Yes, okay. So let's talk a little bit about it. So, first thing is I'm going to subtract 0.4 over.
Yes.
So what do I get when I do that? Good. 0.6. I'm just going to do it the shortened version up here.
Yes.
You work it on your,
Yeah.
okay. And then what's the next thing going to be? I'm going to take 4 times 0.4. Was it 4?
Times 0.4.
Wasn't it? Yeah, 4 times.
So
And then
4.6.
subtract it. Sorry, I got myself lost.
So 2.3 minus 1.6.
And what do you get?
0.7.
0.7. And what I also recognize is the Q
Goes away.
goes away. So really what I have is that.
Yes.
Yeah.
Okay, comfort zone, are we good?
Yep.
Yeah? Now, next, I'm gonna do lots of math at the same time, 2.3 squared, I'm gonna add it over and subtract this over. Somebody must have has that out there in
1.9.
1.9,
Yes.
and then 0Q
Goes away.
goes away. So, the beauty of this particular problem, because it had the 0 in there, made this, the bottom 2 things, 2 equations with 2 unknowns, which we should be very comfortable with, right? So, what are the different ways that we can accomplish this? Yeah?
I did elimination.
I prefer elimination when I see things that don't have like a 1 in front of it, right? So I think we're going to take the negative 3p, I'm in the way, I'll move in a second, is 0.7, and then 9p. We're going to pair these guys up, and we're going to multiply perhaps the top
I
one
did the top
by,
times negative 3.
you did negative 3,
Negative 2.
and then negative 2 would work as well.
Right.
Either way, yes.
So, but like, when would you use substitution and elimination? But
I left that on just in case, no, that's, just in case anybody who calls, any of you guys call. When do we what?
when would you use substitution as opposed to elimination? And
Okay, so substitution is when I have a single, like an example, negative 3p plus 1r equals, and I would solve for the letter r and then plug that in.
because I kind of like the substitution.
Absolutely use
Yeah.
it. But when you do that, you know you're gonna have some fraction action.
Right. Yeah.
Yeah. So, yes.
When you're setting up for elimination, don't you want both of them to have the same, one of the terms to be same, like 9p and 9p, and then you subtract an entire equation from it, right?
Either way, I personally like to take it and multiply it by the opposite, so they're opposite, and I add them.
Yeah, me too. Add.
That's the way I've always done it.
But it's the
Wait, I
same
forgot.
thing.
Yeah.
Either way.
When
Yeah.
you multiply by
Okay.
negative 2, do you have to do it to the point?
Yes, so I personally would take -2 throughout the whole thing. But you know, what is that?
I did negative.
Tomato. There's 2 different ways to call
Yeah.
it, but you can do it however.
I got an answer that makes sense.
You got an answer that makes sense, and I hope I will too. We'll see. So we have 6p, right? If I multiply mine through. Oh, for goodness sake.
Someone's excited to talk to you.
Maybe it's
Times -3, so I got a 9p minus 6r equals a negative 2.1, right?
Oops.
And then when you subtract them, I got down to eliminate the p, I got 10r is equal to 4. And then you divide both sides by 10, and then you get r is 0.4.
Okay, I'm coming. Sorry about all the interruptions. Did you get something for p and r?
I got r, 0.4, and then...
R is point what?
Maybe I solved for R.
I got P is 0.2.
I got. That's not what I got.
Oh.
Yeah, Lance, we should get it.
Can you just,
Yeah, let me finish. Okay, so 6p minus 4r, and what's -2 times 7.7?
negative 1.4. Add them?
Yeah.
Yeah, that's what I did too.
But the
Okay.
4r's, the r's cancel out.
CP equals.
Right.
Yeah. Yeah, that's what you want.
15. Oh.
P equals
0.5. And then p equals,
P equals 0.033.
What was that?
P equals.
0.5.
0.9, 0.5.
so then
And then t is what?
0.03 repeating.
Yes, 0.033. Yeah, I was right.
Then you use those 2 answers, plug them in here inside.
Why do we add it again?
Because I did opposite signs. Remember that's the discussion we had where I multiplied? Because these are opposite signs, if I add them, it gets
I
rid of
got
one of them.
0.033, 0.401,
Uh-huh.
and 0.166.
So you plugged them in here and solve for Q. Okay.
See, I did opposite sides.
Where did you get r? Like, where's the work for the solving for
Okay,
r?
once you find your P,
And you just plug it in.
either or.
Oh yeah.
But you just didn't show that.
I didn't show that yet.
So P equals what?
Time got exciting and I had to go do other things.
And then you could just plug in for, and then solve for
Right,
q.
right, right.
0.033, R is 0.401, and P is 0.16.
Are we good?
R is
Yes.
0.401.
Awesome.
To be continued.
To be continued, baby.